Hi everyone. I just saw you moments ago, and here we are together again. So this is part one. I told you during class that I was going to go through all of the topics that are on this yellow packet, starting with the mean and the range and error bars. And I'm smushing those together because how long do you want to be here? Huh? Huh? All right. I hope you had your coffee because I'm having mine. So here you see your chart. What's on here is the mean. So here, this top, oh, get away from there. But this top part right here, the top of the bar graph, that's your mean. So that's telling you what your average is. And we've had averages forever and always. We've used them forever and always, and they don't really tell us much. So that's basically the mean, right? And you should also know the formula for the mean, right? Which is I add up all the numbers and divide by the number of numbers I have, right? So that's not too shabby. But basically, we started by saying that the mean is really like it's not going to tell us much, okay? Because a mean could be made up of 100 numbers and you could get 12 as the mean. A mean could be made up of two numbers and you could get 12 as the mean. So there are big differences there, especially when you're making decisions between, I don't know, life-saving treatment of some kind, right? The study that has hundreds of people and is well represented by the mean, ACEs, right? Two people, I'm not willing to gamble on that. Okay, this is also where we begin scratching the surface of statistics. So what you're going to notice is that with each video that comes after this is that we just keep digging deeper and deeper into the same thing, right? So at no point are we sort of launching off into a different thing. And it may seem like, wait a second, wasn't that error bars? Wasn't that standard deviation? And the answer is kind of yes, yes, and yes. Because we start with a mean and we just keep digging from there. We're like little naked mole rats, just digging tunnels of math, right? Which sounds as fun as it sounds. Okay, so anyway, so here we have the mean. Here we have a mean of 1.8, and then back here it's looking like 0.95 or something like that. Okay, those are the means. We don't even care what they're measuring. The thing that we care about is we care about the error bars. Okay, so hopefully my little design tool is going to show up a little bit nicer now so I can highlight these error bars for you. Okay, here's my error bar. Okay, my error bar has a bottom and a top. Oh, maybe I can make it better. Oh, look at that. Woo. That's terrible. Better. Okay, so there's my error bar. My error bar has a bottom and my error bar has a top. And what I'm looking for is I'm looking for, okay, that top and bottom, how close are they to the top of this bar graph, right? Basically what that's telling me is how close are they to the mean? And that means a lot to me because if my error bars, as you can see here, right? If my error bars are way, way, way off from this center point, right? The top of that bar graph, which is the mean, then that means that my data to get that mean is all over the place. So the mean, yeah, it looks like it's like 0.95 or something, but that came from data that was super, super scattered. That came from data that went all the way down to 0.6 and all the way up to 1.3. So this data is not really telling me very much at all. This average is kind of bogus. It doesn't really mean anything to me because the data was all over the place. All right. This one, which is labeled phosphate, but again, it doesn't really matter, right? This one is getting a little bit closer to the mean. And then here we have our oxalate, which is really close to the mean. We love that because what that means is that most of our data points fell close to the mean. If I go and I look at the individual points, most of them are going to fall very close to that mean. Most of them are going to be right at 0.8, right? That's what I want to see. I want to see that my average, the top of my bar graph, does a good job at representing my individual data points. If my bar graph has an error bar that's really, really small, think of that really small error bar as being all the data points that's clustering around the mean. That's great. That means that my mean and my individual data points, they're in sync. They're saying the same thing. If, on the other hand, I'm over here, right, and I've got this large error bar, that's telling me that the data points, they're not close to the mean. They're very, very far away from the mean, right? The mean was just the number that you happen to get when you add them all up and divide. But it doesn't actually do a good job of telling you what the data is saying. So that's super important. Next, we're going to be here for a while. You lucky guys. Okay, so next is something I have to actually steal off the internet. So now would be a good time to like put on fuzzy slippers or, I don't know, pet your cat and something like that. And we're back. Here we are. Okay. Another significant part of error bars is whether or not they overlap. I know. So here, there's a whole lot of overlap in between your error bars. Less overlap, no overlap. If we're trying to show the difference between two populations, right? Let's say, again, we're pitting our meat eaters against our vegans, right? If there's a whole lot of overlap, that means we got a lot of the same results from both vegans and meat eaters. That doesn't tell us anything, right? In fact, if it tells us anything, it tells us that there's no difference. There's no difference between a meat eating and a vegan diet because there's so much overlap. So much of our data from meat eaters matches our data from the vegans. So how could I come to a conclusion that there's any difference between the two groups? Spoiler alert, I can't come to that conclusion, right? So moving on, less overlap, all right? We're seeing that there might be a difference between the two groups. And no overlap means there's definitely a difference between the two groups. We don't have data points that match. So I don't have any data points from meat eaters that match up with my data points from vegans, right? So this is telling me that, okay, I've got a difference here. Now, how could I test that I definitely have a difference between those two means, between those two populations? I'd probably run a t-test. An unpaired two-tailed t-test, perhaps? If you know what I'm talking about, then watch more videos. There's another one on t-test that's coming, obviously. So hopefully that cleared up some of the stuff on error bars. I want you to be very, very aware that there is another video on error bars. It talks about putting error bars into Excel. You're not getting tested on that. Nope. So no. So don't do that. Don't watch that video. If you want to get some good practice, which of course you do, you are going to go to your packet, this one. Where is what? Okay, you're gonna go to your packet, this one with all of the lessons listed, okay? And you are going to check out pages 4 and 5. Actually 4 through 9, and that'll cover error bars. Then you're going to check back here a little bit later tonight, and you're going to see what all those answers were, and you are going to compare them. So have fun doing that, and I'll see you in probably about 2 more minutes to talk about something else.